Hey y'all, it's me, Miss B, and today we're talking about domain, range, and asymptotes, mostly focusing on domain. Okay, so the domain, we've talked about it before, is the set of all possible inputs that give real numbers when substituted in the equation. Typically, they are the x values of an ordered pair. All right, so for this one right here, let's go ahead and list the domain. Take a second and do that. For this one, you should have had the domain is 1, 3, 5, 7, 9. Okay. Now for this one here, I'm going to go ahead and list my domain. It's going to look a little bit different, so go ahead and try that one on your own. All right, so we've got 5 and 10. A lot of people would want to list these values. However, we have all these in between values too. So let's not do that. I'm actually going to leave those tick marks on there. So we have all these in between values all the way up, all the domains. So the way that we're going to do that is we're going to say the x is between, and it's included, -5 and 10. And -5 is listed, as is 10. So that is how we'll list the domain for that one. Okay, so there's something we know that we can't do. We can't divide by 0. So I'm going to go ahead and find f of 2 and f of -2, given f right here. So I get 3 over x plus 2 minus 4. I'm actually going to copy this down because this is going to be the same equation, just different numbers being plugged in. So for this one, I'm plugging in 2. When I plug in 2, I get 3 over 4 minus 4, which is, let me work left to right rather than up and down. So I get 3 over 4 minus 4, so I get -3 and 1/4. For this one, if I have 3 plus -2 over 2, I get 3 over 0 minus 4. However, this is undefined. It doesn't exist. If you type in your calculator, you'll get an error. So, because of that, remember, since division by 0 is undefined, -2 can't be part of the domain of this function. So we say that the domain is all real numbers except not equal to -2. So all real numbers not equal to -2, or x is not equal to -2.
Baker, please come to the assistant principal's office.
Okay, so here are some things with finding the domain. Our main question is always going to be, is there anything x can't be? All right, so let's go ahead and fill this out. The first thing, we're not really going to deal with this too much, but is it an even root? Yes, then we're going to set the radicand greater than or equal to 0 and solve. Okay, if there is a fraction, then we have to set the denominator not equal to 0 and solve. Okay, so if I have no to both, then it's going to be all real numbers. If yes to both, then we have to combine our answers. We're just going to focus on these two right here. These are our key things that we're going to be focusing on. Okay, so finding the domain of this function. So I ask myself, is there a fraction? No. Is there a root? No. So the answer is all real numbers. Just using that chart above there. So for this one, is there a fraction? Yes. So I'm going to follow along here. Yes. So I have to set my denominator not equal to 0. So I'm set x plus 1 not equal to 0 and solve. So I subtract 1 from each side. and x is not equal to -1. There's my domain. All right. Save number 3, try it on your own. All right, number 4. Is there a fraction? Yes. Root? No, but we're not dealing with that. So then I have to set my denominator equal to 0, or not equal to 0, and solve. So x is equal to 5. Not equal to 5. Okay. So when we are finding the range, it's going to be this value right here. So this right here will set our range. So let me go ahead and highlight that. So picking out that value, that means that the range is going to go from 4, is going to be y, because we're dealing with y with range. Y is greater than -4. Okay, so it's always going to be for the range, y is greater than your c value. So in this case, it's y is greater than -4. We'll talk about that more in a minute. Okay.